I'm Anil Kumar, and in this video we will learn strategy to express data in the form of an algebraic expression. So what we have here is input-output kind of information, and we will translate that information in the terms of algebraic expression. So the question here is, complete the table below and write algebraic expression for each. Now this is the test problem, and the third one is indeed very difficult. That's a challenge question, right? So we have three questions here, A, B, and C, and this one is a bonus for you to do. Now, I'd like you to copy these questions, work it out, and then look into my suggestions. The first one here is, we are given a table of values where the input values are X, the output is Y. So it's kind of a T table. Treat it like this. Okay, so it's a T table. So let me draw this T for each one of them. You copy the values and try to find the algebraic expression. Remember, you need to fill up one of the values, which will help you to see what kind of pattern is being followed. Now, if you analyze the pattern, you can get algebraic expression. So that's the whole idea, right? Now, to find the pattern, what should we do? So the steps are, you have to see how y can be calculated from x, and you have to see the trend. In the very first one, we see that the x values are increasing by 1 each time, and the y values are increasing by what amount? Let us see. So when I do 4 minus 1, what do I get? 4 minus 1 is 3. Now if I have to move from 4 to 9, then what do I get? 9 minus 4 is 5. And if I do 16 minus 9, then 16 minus 9 is 7. So what I see here is that you have to add 3, 5, 7, and this time you should add 9 to get the next number. So the pattern being followed here is that you start at 1, then you add 3, then you add 2 more than 3, that is 5, 2 more 7. So this is the trend. So what you see here is a pattern. You are adding 2 more each time, and that is how you get a particular relation. So if I add 9 to 16, I get 25. So this is the value which I get. Now that is one way of looking into it. The other way to look into this pattern is probably simpler, and that is, how do I get 1 from the x value of 1? How do I get 4 from x value of 2? How do I get 9 from 3? And how is 4 related with 16? Now if you look into that side, then you can say, well, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. And therefore I could write an expression which is equals to x square, correct? So x square is my expression which works in this particular case. So that is how you need to analyze. So you could have analyzed either way, right? But I hope this is a simpler solution, and I'm sure you must have guessed it even before I guessed it, correct? Now let's look into the next one. So let's see if there is a relation between 1, 4, 2, 9, 3, 14. Well, there doesn't seem to be that straightforward relation. So let's go with our first approach, and that is to find the difference between the terms. So the difference between each term is how much? Let's calculate. So how do I get 9 from 4? By adding 5, right? So 9 minus 4 is 5, 14 minus 9 is also 5, and this is also 5. So there is a constant difference. So if I add 5 to the next number, I should get the missing number, correct? So 19 plus 5 will give me a number, and that is 24. So we get 24 here. So we get the missing number. Now, how should I write algebraic expression to get this number for all the sequence numbers, right? All the terms. So if it is 6, what is the next number? How do I get these numbers? For that, we should define our algebraic expression. We know since there is a constant difference, it is a linear relation where times 5 is key, right? So we have to do 5 times the number and then figure out how do we get the number itself. Now what is 5 times 1? 5 times 1 is 5. How do I get 4? Take away 1. 5 times 2 is 10. How do I get 9? Take away 1. 5 times 3 is 15. Take away 1 gives me 14. 5 times 4 is 20. Take away 1 gives me 19. So I think we know the rule. The rule here is 5 times x, take away 1. So if I follow this expression 5 times x minus 1, I will get the pattern shown here in the t table, correct? Or input-output pattern, right? So the output is 5 times the number, take away 1, or 1 less than 5 times the number, right? So it is, you could write like this also, 1 less than 5 times the number. Now this one, the last one, is very critical. There is no particular order in which x and x values are taken. But we know y is dependent on x as always, right? How do we find this relation? If x is 3, y is 2. If x is 21, y is 8, 9, 4. So we know that the y values are much lesser than x values. Okay? 30, 10. Well, what is 1/3 of 30? 1/3 of 30 is 10. And how do I get 11? By adding 1. Okay. Now that works. So what I did here is I did 1/3 of 30 plus 1. So I got the value. Okay. Let me try the same strategy here. These are all multiples of 3, correct? That gave me an idea. 3 is 3 times 1, 3 times 7, correct? This is 3 times 3, and this is 3 times 10, correct? So what I found here was that the numbers on the side were kind of, this is like 3 times 1, this is 3 times 7, this is 3 times 3, this is 3 times 10, this is 3 times 20, right? And the y value is 1 more than what it is 3 times. So 1, 2, 7 and 8, 3 and 4, 10 and 11, 20 and 21. So that is how I got my value, correct? Now the expression is kind of like this, because 3 times the number plus 1 is what I'm getting as the y value, and therefore I could write this expression as 1/3 of x plus 1. You get an idea? So 1 more than 1/3 of the number. So it is 1 more. It is 1 more than 1/3 of number. So at times you could get very difficult questions, but then you have to think, how are these two values related? And I hope this 3 times 7 is 21, and then y is 1 more than 7 helps you to understand what kind of algebraic expression could represent the given sequence of numbers. I hope this exercise is helpful. Please share your remarks and share it with your friends. Thank you and all the best.